And an example of that would be the Eagle, the Demon, the Shockwave. Another type of roller coaster is where we do mechanical work and we get all KE out.
Their method of using the amusement park as a giant physics classroom is so successful, they'll pass it on to other teachers today.
Here, work must be done initially to give the ball bearing potential energy, okay? Once that work has been done, we can tap it just like we did with this roller coaster. And you'll notice, believe it or not, that's intentional. We modified this track. There's a lot of physics, a lot of science in why that ball jumped the track, folks. But this device, indeed, is like the Shockwave, like the Demon, in that the energy is transformed from potential into kinetic, back into some potential, and then finally brought to rest here at the end.
Now,
Jim and Chris started team teaching physics at Barrington High School outside Chicago almost 20 years ago. This year, Chris moved to a nearby high school, New Trier.
Jim and I really believe...
Bring it up to the edge. There you go, right there. There you go.
Here we go, enjoy ride.
Some of these teachers are taking their first ride ever on the tidal wave, still wondering whether this is the way to teach physics.
Now, I'm sure when you had high school
Don't
physics,
behavior problems.
you had formulas, and how much do you remember? They get out here and they do it.
They're going to apply
remember it.
Now it's the students' turn. The amusement park classroom always begins with a stop in the park's picnic grove, where Jim and Chris put on a sideshow of their own.
Off on a tangent. Again. Find the roller coaster.
Well, you know, one of the things about Einstein's theory of special relativity is that it's impossible to detect your absolute motion through space if you're moving along with a constant velocity. But
One of the first things today's field trip drives home is the difference between velocity and acceleration.
Yes, indeed. Well, how can you have an acceleration when there's no change in speed?
Velocity is speed and direction. Acceleration is the rate at which your velocity is changing over time. The Indy 500 is a test of speed. A drag race is a test of acceleration.
If you start out at zero.
Okay, there's a weight hanging from a string, okay? Now, if we move with a constant velocity, what will the weight do? It'll stay the same. As Hicks said, it's impossible to tell if you're moving with a constant velocity. If you're in a car that's at rest, it hangs. If you're moving with a constant velocity, hang straight down. Jim?
Yeah, so as Mr. C mentioned, if we accelerate in this direction, the weight will respond in the opposite direction.
Today, the kids will get a chance to measure acceleration, their own. And in the process, they'll learn the difference between PE, potential or stored energy, and KE, kinetic energy, or energy of motion.
What roller coasters does this remind you of where we do work, but it goes into all KE at the beginning? The tidal wave. Okay, let's take a look at this. Now, what if the track is missing at the top? Will we have a chance to still make the turn? Well, in order to make the turn, you need a force towards the center. I don't see a track up there. There's no force up there to keep us. Any ideas?
So what you're saying is, if we open up the track, we still have a chance of making it from this section to this because gravity is going to supply the needed centripetal force.
Can you imagine the ultimate ride?
The ultimate ride.
Ultimate ride. The track is missing. Will we make it? Yes, yes, we will.
Are you ready?
Yes, Mr. C. Now, just the right speed. Let gravity do the work. Okay?
Yes! Did you see that? Hold it, hold it,
Okay.
hold it. Let's widen the gap, shall we?
No. Do we go to limits here?
Let's go to the limits.
How wide?
How wide? One car? Let's go for a car.
See, I don't know. I don't know. It's going to be tough.
Yes!
All right. One more thing.
Oh, I see. So everybody has to make one?
Before the class takes off for the rides, they quickly assemble their homemade accelerometers. The straw will help them sight into the top of the ride, so the string and washer can show the angle on the protractor to determine acceleration.
In order to measure the potential energy at a particular location, First, you have to define where the zero potential is, and then we have to measure everything with respect to that zero potential energy line.
The kids also learn some things about G-forces, which is a way to express the acceleration we feel due to the Earth's gravitational pull. You and I are feeling one G-force on us right now.
Feel like you're being getting greater and greater?
Riders on the Cajun Cliffhanger feel about 2.7 Gs, which is about what it would feel like to go for a stroll on Jupiter.
Oh, there's a shockwave now.
Okay, Matt, from there.
Okay, so we'll have an accelerometer now. What will happen up there?
Oh, well, when we go down and stuff, it'll show it about, I don't know, however fast you're going, so it went like that. It would use that angle and take the tangent of it, and through that we can find out how fast you're going, like the force vector that we've used.
What if you throw up before that?
On the tidal wave, I like that one a lot because we measured the wavelengths and we got to find out our speed, and it was amazing how fast you were going.
We had all our formulas written on the board, but when we got out here, we could actually put it to use.
You can find out the force of the shockwave rolling down because you know the mass, and you know the acceleration through the use of your accelerometer.
Why don't you be Uncle Jim and Mr. C for me here and teach me a little physics by using the park? Choose anything.
How about the condor there?
Okay, great.
Okay, if you see how they're spinning out there, the radial acceleration, which is the acceleration towards the center, is what's causing the force to swing the cars outward more as they circle around.
Let's measure that on the outside first.
One of Uncle Jim and Mr. C's secrets is really no secret at all. It's their incredible enthusiasm. Even after dozens of times, every ride is a new thrill.
Just by taking their accelerometer.
Well, I think that Jim and I are just kids at heart. We enjoy having a good time right along with our students, and I think we really like physics.
I love the eagle.
Let's do the eagle.
Let's go, the eagle.
That's my favorite.
What's the secret to their success? Well, I see motion sickness in that incline, but to Mr. C and Uncle Jim, it's the Super Bowl of physics, the Final Four. Watch and listen. They were teaching all the way.
But we'll be able to actually see that sort of levitate.
Exactly. The string should go limp as we go over the humps. I was just thinking, when we go around the spiral, Jim, we can get the centripetal accelerations that spiral through there. This should lean out at the end. Oh, boy, here we go.
Here we go.
Okay, Alicia. All right. I really do love this ride. Classroom, of course, that kind of stuff. No, really, you talk about it, but boy. That's great.
We achieved weightlessness.
Weightlessness. That was fabulous. That was just the best.
They've known the thrill of discovery. That's why Mr. C and Uncle Jim are new explorers.
They're the most incredible physics teachers. You get so excited. They get excited about it. It's great. Little kids on caffeine.
Good. That was good.
It's not just straight out. This is what you have in physics.
Jason was headed southwest, and when we hit,
They bring life to it. It's more colorful.
I used to not be interested in science before this year, before I took physics, and now I go home and tell my mom about the things we did.
He approaches each subject as if he were